Okay, let's dive right into this explainer. Today, we're tracing an absolutely incredible journey of human communication. We're looking at how we evolved from tossing around simple subjective descriptions to developing a truly universal language of science and measurement. It's a journey that takes us straight down into the fundamental building blocks of reality. We are stepping away from all that ambiguity and firmly into the realm of undeniable fact. So think about everyday language for a second. What exactly is an adjective? It's our go-to tool for sharing experiences, right? It paints a picture, colors our world, adds emotion, and really helps us connect. But here's the catch. When we need to truly understand the physical universe, our everyday language falls remarkably short. I mean, an adjective is incredibly useful if you're writing poetry or telling a good story, but from a scientific standpoint, it's nowhere near enough to actually grasp the nuts and bolts of the world we live in. Take a classic tough guy character, for example. If you're relying purely on words to describe him, you'd probably reach for adjectives like bald, or maybe strong, or intense. And sure, those paint a helpful mental picture, but they're completely subjective. They rely entirely on whoever is doing the observing. Your version of what constitutes strong could be wildly different from my version. We aren't actually sharing precise data at all, we're just tossing our personal perceptions back and forth. Even if we shift to describing something much simpler, say a blocky yellow figure, the exact same problem pops up. You can call it yellow, you can say it's smiling or made of blocks. But wait, how yellow is that color specifically in terms of actual light wavelengths? Or how large are those blocks compared to each other? See, an adjective gives us the flavor of a subject, but it ultimately robs us of any real precision. Or consider a simple wooden box. Calling it heavy or sturdy works perfectly fine if you're just chatting. But imagine the real-world application here. What if you're trying to load that specific box onto a highly pressurized cargo airplane? Or maybe you need to fit it into a precisely engineered storage unit in an automated warehouse. Saying, well, it's heavy doesn't help anyone. We absolutely have to know exactly how much space it takes up and exactly what its weight is so we can safely balance that aircraft. And that brings us to a huge realization. It brilliantly illustrates the critical difference between judging a subjective quality and rating an objective quantity. When we rely entirely on qualities, we're wading into matters of opinion, human perception, and biological variance. But quantities? Quantities are matters of undisputed fact. Moving from a subjective quality to a hard objective quantity is literally the bedrock of human technological progress. It's the one thing that allows us to truly understand, replicate, and manipulate our physical world with absolute certainty. Section 1. Why measurement matters. Measurement is an absolutely vital survival skill when we're talking about modern infrastructure. We've all seen the classic "trust me, I'm an engineer" meme, where someone is recklessly hacking away at a load-bearing wall. It's funny, right? But it highlights a pretty terrifying truth. Unless you want an absolute disaster on your hands in construction or structural engineering or advanced manufacturing, you simply cannot rely on guesswork. You have to measure. Our entire modern society is built squarely on the back of exact calculations. But hey, it's not just for the engineers. Precision is just as valuable for our everyday lives and our hobbies. Just think about a simple measuring cup in your kitchen. The difference between adding baking powder precisely by the gram versus just tossing in a casual pinch is literally the difference between a perfectly risen cake and a collapsed, sad culinary disaster. Whether you're mixing chemical epoxies for a quick home repair, doing some delicate woodworking in the garage, or just following a complex recipe, measuring bridges that crucial gap between a failed experiment and a perfect, repeatable result. So what is measurement at its absolute core? Well, it's formally defined as a process of computing the amount of an unknown physical quantity by using a standard known quantity, which is a really profound concept when you stop and think about it. It means we can't understand a physical thing in isolation. Every single measurement is an act of comparison. We're taking something we don't know and we're comparing it directly against a universal, reliable yardstick that we do know. Section 2. The global standard. But this whole act of comparison raises a massive question. Whose standard yardstick are we supposed to use? In the past, having arbitrary local standards caused some massive friction. So, to avoid total global chaos in trade and science, the world desperately needed a unified, agreed-upon way to compute these comparisons. Enter the International System of Units, which most of us know as the SI or metric system. This is our globally accepted language. Whether you're a scientist working in a lab in Tokyo, a manufacturer in Berlin, or a student learning physics in New York, the SI system ensures that when you state a specific measurement, the rest of the world knows exactly what you mean. Now, the true beauty of this globally accepted system is its elegant simplicity. You might logically think that capturing the immense, staggering complexity of the physical universe would require thousands upon thousands of different foundational measurements. I know I would. But in reality, it all built upon just 7 foundational base units. That's it. Every single other unit of measurement you can think of, velocity, pressure, force, energy, is ultimately derived from just combining those 7. Let's actually walk through them, because these are literally the building blocks of reality. For the basics of our physical space and matter, we use the meter for length and the kilogram for mass. For the relentless flow of reality, we track time with the second. When we're dealing with energy and atomic movement, we track electric current with the ampere and thermodynamic temperature with the Kelvin. And finally, for the deep building blocks of chemistry, we have the mole for the amount of a substance and the candela for luminous intensity. Just 7 units, unlocking the infinite possibilities of science. So I'm going to leave you with this amazing thought to ponder. Everything we can physically quantify, everything we can ever measure, traces right back to these 7 basic units. Isn't it absolutely fascinating that the entire known universe, from the staggering, incomprehensible mass of a distant galaxy, all the way down to the gentle brightness of a single candle on your dinner table, can be completely mapped by just these 7 simple building blocks? The next time you measure something, stop and ask yourself, which of these universal keys are you using to unlock the secrets of the physical world?